small, fun and sensible. Now that is something that we like to politely promote on the channel. But things that are really small, incredibly fun and very, very sensible, they do require rather a lot of very large, incredibly unsensible bits of technology underneath. And that's called innovation. And nothing epitomises that more than this, the McMurtry Spéirling.
Now the McMurtry Spéirling, an electric single-seater fan car that set blistering times on the Top Gear test track, smashed the Goodwood Hill Climb record, and can generate so much downforce it can actually drive upside down. It's ingenious, it's outrageous, and somehow, if you've got enough pocket money, you can actually buy one. So we're here to find out how, and perhaps more importantly, why.
Our 3 free YouTube channels on EVs and clean tech are funded by our fun-packed test drive-tastic events in Farnborough, London, the Southwest, the North, Melbourne and Sydney, and next up, Everything Electric Melbourne.
And you for UK viewers, you can buy a battery electric vehicle or more at everythingelectric.store. Back to the episode.
0 to 60 in under 1.4 seconds when that fan's working perfectly.
We just want to be able to build something that's within a small package that is just the fastest car ever made.
Listen to this. Ready to go. And it's nearly blast off. Look at that.
No rule book, no restraints. How do we make the fastest car, full stop? And I had a meeting with Sir David where he just said simply, suck it to the ground.
In turn 1, look at the way it sucks itself straight down onto the track.
Yeah, you can see how the fan at the back, that creates 2,000 kilos of downforce. It grips the car down. It's got 1,000 horsepower. It's a tiny car as well.
A small single-seater electric car with maximum performance, but with a fan downforce system to give it more grip than has ever been seen since, or seen to some extent in the 1970s with the Chaparral 2J and the Brabham BT46B.
3.51 seconds over the first 100 metres, 17.34 seconds at intermediate 1, and I can't hardly read it out as quick as he's getting to these points at the moment. Through there he goes, 28.24 at intermediate 2, and he's already heading up towards the line.
Certainly in the modern era, it's a car that defines new levels of what is possible.
What's it going to be over the line? Is it going to be a new record? Of course it must be a new record, surely. 39.008, 39.08.
McMurtry first grabbed the world's attention with a silver prototype that hit 150 miles per hour during its record run. Today, this blue car, set for customer delivery in 2026, take things up a notch. Armed with its 100 kilowatt-hour battery, a lightweight 1.3-ton chassis, and a blistering 0 to 60 mile per hour time of just 1.5 seconds, it can reach a staggering 190 miles per hour. At the heart of every McMurtry is one audacious idea: a downforce on-demand fan system capable of generating 2,000 kilos of downforce, and all from a standstill. We are here with the clear mission to find out some facts.
Yes.
I want to find out about the fans.
I want to find out about the batteries. I'm obsessed with the batteries. Their batteries are bonkers.
Shall we go and do our homework?
Let's go and do our homework.
Yeah. So key to the downforce is, of course, the fans, basically vacuuming this to the ground. Can you describe A, how that works, and B, why that was identified as the way to do this?
Yeah, absolutely. So we have 2 fans at the back of the car here behind the driver's head, and those fans together, they generate 2,000 kilos of downforce regardless of what speed you're going. So they suck the air out from an area underneath the car, and they create an area of low pressure that just sticks the car down. So we've recently demonstrated how powerful this system is by driving the car upside down. I don't know if you've seen that video, but
Yes, I've got a question about this, because if you've got downforce sticking it to the ground, when it goes upside down, is that downforce then upforce?
yeah, well, that's how it's been described by some people, yeah.
You drove the car upside down.
I did.
How did that feel, and what precisely was going through your mind at the time?
I'd love to say that it's this wonderful experience, this sort of transformative experience driving a car upside down. Honestly speaking, it's like being hung upside down in a set of straps, and it's not entirely comfortable. And to drive that car upside down unstrapped and think about the consequence of writing it off if it falls off was incredibly stressful.
So obviously on a track you would hope that there aren't any potholes, but what happens if there is a pothole when you have that vacuum system and that skirt?
So firstly, the skirt is quite narrow, so the car's been designed so that it can hit curbs on the side of the track and you still maintain contact with the ground, so you're not losing pressure. Now, there are times we've been to tracks where there have been some potholes or areas, some really poor tarmac, and when the car goes over it, you momentarily get a loss of downforce, but as soon as you're past it, it grips up immediately. So from the driver's perspective, nothing's really happened. In the same way with a race car with wings, because of yaw bumps, you always have momentary fluctuations in downforce, and it's the same with this car. But to the driver, for the driver's perspective, you always have that confidence and that grip.
So in Formula One, for example, wings are the more common approach to achieving that downforce. The vacuum maybe less so. So why, firstly, and secondly, what have you had to invent here to make this possible?
Okay, that's a very good question. So F1, most race series, they use big wings, lots of aero devices that are dragged through the air and generate the downforce. Now, this uses a lot of energy. The drag means you have a lot of energy to just push the car through the air at speed. And on an EV, this is not ideal because you have limited capacity, and obviously a battery doesn't have the same energy density as petrol. So we wanted to make sure we had the most efficient car we could, and we identified that having two fans, on average, to generate 2 tons of downforce, we're pulling about 60 to 70 horsepower, whereas to generate the same amount of downforce on a race car, you'd be using way more power than that. So using the fans, not only does it give you downforce, consistent downforce at whatever speed you'll be doing, but it also uses way less energy than using traditional aero devices.
So this is astronomically much more efficient to drive than, say, an F1 car.
Yeah, and safer. We've had times where our drivers have spanned the car, and you still get full downforce going in reverse. Whereas with no traditional aero, you start going sideways and reverse, you get lift, the car just flies off the track. Whereas you spin, lose control, stamp on the brakes, and come to a stop before you even left the track.
So the team at McMurtry have been very kind. They are letting Imogen start the fan. The fan is quite loud. That's why I've got these on. She's got them on too. Woo! Okay, let's go. That is bonkers.
We've designed the whole system in a way that aerospace would design engines on an aeroplane. We make sure that if there ever is any issue, that the car is safe. So you can have one fan shut down and you only lose about 20% because you have a second fan still generating most of your downforce. Your battery system, if there's an issue in the battery or a contactor wants to open, we have dual power supplies. So even on the LV system and the communication, the whole thing, there is any issue on any part of the system is okay because there'll still be a secondary system keeping it running.
You said that there's had to be loads of stuff that's been invented or created in-house. What's the weirdest or most annoying thing that you're like, ugh, we're going to have to make a version ourselves?
Where do I start? I could look, we have quick jacks here. So we have a customer will be able to press a button, the car lifts up. Now, there's off-the-shelf systems that do that. There's pneumatic systems which are quite big and require a customer to have a big air tank coming up to the car, plugging that in to lift the car. We thought, okay, we have our own hydraulic system in the car, might as well use that to lift the car up. And since we have a hydraulic system to control the ride height, which we had to design ourselves because nothing off the shelf fit in a car this size, we thought, well, let's use it to power the power steering system as well. but it's everything. Wherever I look at, I look at the wing mirrors, 3D printed aluminium, 0.7 mil wall thickness, incredibly light and easy to make. And it's so many things. Wherever I look at this car, there's interesting bits. Wheel nuts. You wouldn't think much about a wheel nut, but one of the engineers saw that. Most race cars have massive torque wrench, which is really hard to use. We don't want customers having to carry that in the truck, so we invented a small little torque multiplier, so you can use a normal torque wrench, a small torque wrench, and the torque multiplier allows you to put way more torque through the wheel nut, and it's much easier. So a lot of the focus has been, how can we enable our customers to run this car without having to have a whole race team with them? It's all about making it as easy to use. Turn up to the track, do a day of running, drive home, great.
The origins of McMurtry started all the way back in 2014 with Sir David McMurtry, who at that point of 75 decided, right, now is the time I'm going to start a car company.
David McMurtry, a legendary British engineer and entrepreneur, best known as the co-founder of Renishaw, a world-leading precision engineering company. McMurtry made his name designing highly specialised measurement instruments, the kind of kit that allows aircraft engines, medical devices and cutting-edge tech to be made with incredible accuracy.
On day one in October, 24th of October 2016, we were sat there with just 5 people on the floor in the office, and Sir David said, "You've got £1 million and you've got 1 year, give me a car company." And that's how it all began.
The remit was clear: to push the boundaries of what's possible in small, efficient and thrilling electric vehicles. The Spéirling is the first product of that vision, and of some pretty radical engineering. It's this ethos that makes McMurtry's quest to search for the most accurate modelling and optimisation of its battery cells somewhat unsurprising. So Chris, let's talk batteries, because I think what you're doing, what you've been able to do with this car, I can't believe you've got 100 kilowatt hours of battery pack in this very, very small car.
With the concept of the vehicle, it doesn't lend itself to a traditional style battery pack like the Evira might have, for example, where it is in the position of the mid-engine,
Right.
or if you have a traditional OEM, they often usually have skateboard
like a
platform.
skateboard, yeah.
Exactly. And all of that raises the driver up. You're sat on top of the battery.
Right.
Your weight's very low, but the car then becomes very tall.
Yeah.
And this was really about designing the battery organically with the chassis. So the
Right.
battery itself sits within the main survival cell of the car, so under the bodywork inside the chassis. You've got 2 large side pods that run alongside you, so you have then a firewall inside here.
Yeah.
Part of the battery then underslungs the driver's LMP1 driving style
Right,
seating
so
position.
that's underneath my knees, because
Exactly.
I'm sitting like that.
Exactly, yeah.
Right.
So then it goes back round the other side to give you that U-shaped battery. And what that gives you is a really, really precise control on the weight distribution of the car.
Right.
With the battery itself being 100 kilowatt hours and the car weighing just over a tonne, that is a huge proportion of the vehicle mass.
Yeah.
So we need to control that and work with the chassis team
Right.
to design that with the vehicle dynamics in mind, so that you can tune the vehicle dynamics of the car with using the battery as a ballast where its position is.
Right. But I mean, I just want to put some of that in context for us normal people, is that the weight of this car, the only other commercially available car that is of the same weight is the Dacia Spring, which has a 26 kilowatt hour battery.
Yeah.
And you've got 100 kilowatt. I mean, 100 kilowatt hour battery is usually in like a Ford pickup truck
big
or a
SUV,
big Tesla or a
yeah.
big, so that is a remarkable, so that is, the energy density then of those batteries is pretty extraordinary.
Yeah, so the energy density, part of the reason why we needed to vertically integrate ourselves was that we needed a form factor that no one's made. So we arranged the batteries in a very complex manner that means that we needed to control everything from the cell up.
Right.
But that also enabled us to have a go at questioning, why does industry standard modules, for example, do it that way? Can we make it smaller? And what we've actually ended up with is a just under 5 kilowatt hour standard module that is quite comfortably going to be probably the most volumetrically power dense module, but is also on par, so over your 200 watt hours per kilo metric of what most OEMs will be claiming on their module level as well.
Right, wow. So that, I mean, the one you showed me, I could not believe that was 5 kilowatt hours. I mean, it's tiny. You know,
Yes,
the size of a little tea tray. It's like the size of a big birthday cake.
Yes, yeah.
people talk about battery technology being the limit and the limiting factor that determines how good a car or often technology can be at this point. But rather than seeing that as a barrier at the moment, I have to say we see that as just a huge opportunity. The pace of improvement of cell technology is such that we will live in a world in the future where it's possible to genuinely have lighter electric vehicles, more compact electric vehicles than the equivalent petrol versions. The essence of this company is around creating something of that ilk, something that we can be really proud of, that really is great for the driver, but great for society as well.
Other OEMs seeking that same high performance are now able to license or buy some of McMurtry's technology, including these compact battery modules in either 54 kWh or 100 kWh versions. Now, these OEMs can also license or buy the Downforce on-demand fan system and high torque density powertrains.
But then the other things you've got to deal with then are heat, presumably, obviously safety, which I know you've done an amazing job on, but then presumably when batteries are under the kind of level of, I mean, that's the difference between this car and let's go stick with the Dacia Spring. You generally aren't thrashing the Dacia Spring around a track. You're going to the shops.
Yes.
You know, you're driving to school or whatever. So how do you manage all that heat?
Yeah, so it comes back to cell selection. So there are a few things that are important with us with cell selection. So power density is obviously a big one. Where the niche bit of this car is that there tends to be two areas of cell that exist. You have energy cells or power cells.
Right.
Being in an automotive application, it needs to be usable. We needed a big battery because we needed the driver to run out of juice before the car ran out of juice.
Right.
So it's all about it being a driver experience for the customer. So it needed to have a decent battery, a decent range battery. So we're kind of in that grey area where you're in between a power cell and you're in between an energy cell. You're kind of neither here nor there.
Right.
And that's where the cell selection comes in. So you look at things like your performance. So you're looking at impedance. So that's resistance.
Right.
So the resistance of the cell, and that, for the most part, correlates to the heat that the cell generates when it's under load.
Right.
It also dictates the amount of voltage drop that you have. The higher the voltage drop, so the lower the voltage, the more heat that the cell's going to generate because the more current it's pulling.
Right.
So the better performing cells that you can get, so the lowest impedance possible, that's where you want, that's the sweet spot. But you also need enough capacity in there. And then it's really about understanding what happens at a cell level. So we've been able to do this because we've started with a cell and then worked our way up to the pack.
Right.
But in order to be able to do that, the cell data sheet may only tell you 10-20% of the cell. It's like a little window that gives you like little snapshot into what the cell is.
And you need to know a bit more than that.
And we need to know a lot more than that, yeah. And that's where we've worked with partners at About Energy. So they are a UK-based technical partner with us, and what we've really done there is a really technical deep dive.
So we recently started working with McMurtry, who are developing their new McMurtry Spéirling car, and they needed to accelerate the development of that car. New cells are coming to market all the time, even from their partner Moli Cell. So what we help them do is turn that latest cell into a digital simulation model, so they could iterate through that virtual design much more rapidly than in real life. And that saved them 7 months of development time and reduced the time to market for that car for 70%. So there's a really common misconception in the battery industry that the cell manufacturers know exactly how the cells work and they have all this digital data. But where cells come from is a world of material science, where material scientists are mixing chemicals together and just testing it to see what makes the world's best battery. That digital understanding of exactly how batteries work, we still don't have that anywhere in the world. And what About Energy has is a team of software engineers, mathematicians, physicists, and engineers that are playing catch up to that later. And this is really common in the world of material science, where material scientists make the materials first, and we develop that digital and theoretical understanding later.
And really then that, when you've analysed the broad spectrum of the characteristic behaviour of the cell, the amount of heat that it's going to generate, what its life is like under those thermal loads, so operating at high temperatures, under really high charge rates, high regen rates, and high discharge pulse power profiles, that then enables you to basically work out what type of cell you're using. We're quite lucky where we have a technical partnership with Moli Cell, and so the production vehicle will run into production with a P50B, which is a 21700 cell, so very similar to what you get in your Tesla Model 3. So, but the power density of those, you can be drawing close to 100 amps per cell on those.
Per cell, right?
Yeah.
Which would be way above what you would pull in a road car.
Exactly, yeah. With a Model 3, you may be, I don't know, pulling 10 to 15 amps, if that, per cell.
And you can pull 100.
100, yeah. Yeah.
Because every single statistic with this car is like, it's not just a bit more.
No, it's a lot
like
more.
An unbelievable amount more.
What are some of the things that passenger cars could learn from the work here at McMurtry?
So there definitely are exciting applications within passenger cars for the work that we've done. And I simply put, I don't feel in a position to tell you what they are yet, because we're working really hard on how we can take this technology and make it applicable more than just to more than just the track. The racetrack is a wonderful place to show what the downforce system can do, but there are way more things that can be achieved with this technology. So sorry for not answering your question too directly.
If we do stuff about racing cars or sports cars or anything, it's very, very esoteric. It's very sort of elitist, and it's actually some of the technology they're developing here. It might take 5 years, but the fact that I saw a 5 kilowatt hour battery that's tiny, when we know that at the moment that's about like that, and now it's like that, that will leak through so that you'll have smaller, more powerful batteries in electric cars that will go further, that are lighter, that have less of an impact.
And that is 100% the intention here, is that how can these things manifest in stuff that everyday people consume? And there's been a lot of like wink, wink, nod, nod, can't talk
tell you
about
yet.
these things, which is so exciting because we'll have to just cover it in a few
We
weeks' time.
saw doors that we couldn't look through. Really special stuff going on. We don't even know what it is. Very good. But I've had fun today. It's been really good.
I had a lot of fun.
And I'm actually relieved that they went, well, you must have a go in on a track. No, thanks. I'm fine. I'll watch it.
I will test drive it at 20 miles an hour.
It's 20 miles an hour. It's plenty fast enough for me. Anyway, that's good. We should shut up.
We should shut up.
Please tell your friends.
Yeah. Like and subscribe.
And as always, if you have been,
Thank you for watching.
what a pro ending. Jesus, what happened? It's that lunch.